So now we're going to do an example for the flow around the cylinder and see what happens. So in this particular problem, what we are interested in is we got a 2D cylinder with radius A, and the A is equal to 1 feet. And we have a total length of 10 feet. When we are talking about the length, we are talking about this length, right? This is the length that we are talking. So we are saying the cylinder has a total length of 10 feet. And this is immersed in water, and the water flow is 10 feet per second. The density of the water is given here. And we want to add, the question is, what should be the required circulation such that your stagnation point is exactly at 30 degrees? Okay, so that's the problem we are trying to solve. So the first thing that we do is when we have no circulation, when we have absolutely no circulation, so we know the stream function for no circulation is given by 1 minus a squared r squared sine of theta. And you can see here that no circulation is actually equal to 0 at r equal to a and theta equal to 0 or pi. Okay, so this is no circulation. Now, with circulation, your problem changes now, right? So your circulation is the same problem that you had before, 1 minus a squared r squared sine of theta. And then you're going to add the expression term here, 2 pi r plus the constant. And the constant is found by the fact that you know this has to completely be 0 at r equal to a and at theta equal to 0, let's say. So when you plug in those values in there, you immediately find that your constant is actually equal to gamma 2 pi natural log of a. And we actually derived this in class, but you should always try to rederive this whole thing. So the total circulation then is actually your stream function for this problem would be minus a squared r squared sine of theta minus gamma 2 pi natural log of r over a. So this is your stream function, okay? So you need your stream function so you can find your velocity. Number 3, so you can find your velocity. And note that your velocity is nothing else than the radial component plus theta component. And just remember that we did this in class where we showed that r was actually 1 over r partial of psi respect to theta is equal to infinite 1 minus a squared r squared cosine of theta. U of theta will be minus psi respect to r, and that gives you minus u infinite 1 plus a squared r squared sine of theta plus gamma 2 pi r. Okay, so we did this, and we also showed in class that this whole term right here at the stagnation point, at stagnation, we have the following component. there's a dash missing there. And we showed in class that at stagnation, your sine of theta at stagnation was actually equal to gamma 4 pi a u infinite. Okay, so the question you are asked in this particular problem is, what's the value of gamma such that your stagnation value is actually equal to minus 30. So when stagnation is equal to minus 30 degrees, then I can switch this back to gamma. So this is sine of minus 30 is actually equal to minus 1/2. And then if I put this back here, gamma, so that the minus minus signs will cancel out, u infinite, okay? Then from here, you can solve for gamma, and that gives you 4 pi u infinite a sine of, this is a times 1/2, and that gives you 62.83 feet squared times second, and that's the value of your circulation. Okay? Okay, for this circulation, the question is, the next question of your problem is, what is the lift? The lift generated by the cylinder. Okay, so one thing that we did do, we derived this in class. So we derived in class that in a cylinder, your D was actually equal to 0 because of the Lambert paradox, and the Joukowski theorem allows you to find lift per unit span. Or if I don't want to use lift per unit span, that will give you minus rho times b u infinite times gamma. Okay, so in my problem, I have all of these quantities. They're given in my problem because I know that your problem, this gives you a value of this gives me a value of 1.94. This is slux feet cube. This is 10. This is 10 feet. The length of the span. This is 10 feet second. I just calculated this 62.83. So when you multiply this whole thing, this gives you 189 pounds. So this is the total lift generated in my problem. And so when I have a circulation of 62.83, this is the amount of lift that's going to produce. Okay, so that's basically it for example, the first example.